So a wave is a disturbance. Okay, I already told you that. So a wave is a disturbance that travels through a medium or a space, and a wave can be classified into two categories. The waves can be classified into two categories. The first category is mechanical, and the second one is electromagnetic. So which means we have two types of a waves. So the first wave, two types of a wave. Are you still here?
Yes, I'm still here.
We have two types of a wave. So the first wave that I'm going to talk about, the first one is mechanical. And the second waves are electromagnetic waves. It's electromagnetic waves. So in these two types of waves, where mechanical waves, they travel through, they require a medium to travel through. Did you take a note or should I erase here now?
You can erase. I did take notes.
So when we talk about mechanical wave, so the mechanical wave, they require a medium to travel through. So it requires so example of a medium to travel through, it can be water. These are examples. It can be water, and also it can be an air. So those are examples of the medium that it requires to travel through. So it can be water or it can be air. That's a mechanical waves. So we also have the other examples also. So the other example that I can also give you that the mechanical waves include, it can also be a sound wave. And then the other one you must also can be also sound wave. It can be because of water. I can also just say ocean waves, they are still fine. So now we're gonna go to mechanical waves. So we're gonna go to electromechanical waves. Electromagnetic waves. So with electromagnetic waves, on the other hand, do not require a medium and can travel through a vacuum. So with the electromagnetic wave, they don't require a medium at all, but they travel through what? They travel through a vacuum. They travel vacuum. So when we speak about the vacuum is a space whereby in the air on top there, whereby when everything gets there, you can also, even a human being or anything, it can hang there, or you can even walk in the air, in the space, like in the air. So that's a vacuum space. So in terms where in the vacuum, about the gravity, force of gravity, they don't apply there. So everything just move freely. There force of gravity, they don't apply in vacuum. So that's also one of the places whereby my electromagnetic can travel through. So the examples of electromagnetic are radio waves, so the first example that I'm going to give you is a radio wave. And then the second one that I can also give you, it can be also a microwave. This is just an example. So this example that I'm giving you, they can help in a test. If they can ask you to mention, the question can say mention 3 examples or 2 examples of electromagnetic waves. You must remember that it can be a radio wave. It can be also a microwave. And then it can be also infrastructure radiation, not infrastructure, infrared radiation. Radiation. The other one can be, I'm just gonna read them or just tell you the other ones. They will be, it can be also visible light. The other one can also be an X-rays. And the other one can also be a gamma rays. and then ultraviolet radiation. So those are the examples of waves, of electromagnetic waves. So everything, because we are going to be doing more of calculations. So the wave, it can also be, a wave can also be described by their wavelength. A wave can also be described by wavelength. Wavelength, it can also be described by frequency. And also an amplitude, and an amplitude. Amplitude. So when we talk about the wave, the wavelength is a distance between the 2 points. Because a wave, as I've indicated to you, that it can start from, it can be drawn as this way. So it have a starting point. This can be a starting point, which we can mention it A, and this can be an end point, which we can label it as B. So the distance from the starting point there of a wave from here to there, we call it a wavelength. The distance of a starting point, we call it a wavelength. So which means it's the distance, a wavelength is a distance. Is the distance between 2 points. Is the distance between 2 points. And then a frequency, when we talk about the frequency, a frequency is the number of cycles per second. So when you write a frequency, you will find that a frequency is something that will start. Let's say in mathematics, when you deal with frequency tables, they will tell you that you start at 1, maybe end at 0 to 0. Then after that is gonna be is less than 0. Then after that is gonna say less equals to. Then you start at 11. Then it's less equals to 20, like that. So it have a cycle whereby if it's 1, it's going to round until it come back. So this cycle, it can be formed in per second, and it can be also be formed in a minute. It depends on the question. And also an hour, can be an hour cycle, So with frequency, the frequency is the number of the cycles per hour. So is the number, let me just write it down, is a number per second. So that's the frequency. I also mentioned an amplitude. What is an amplitude? So an amplitude, if in mathematics, when you draw a graph of sine, let me erase here, an amplitude in mathematics So when you draw a graph of a sine graph here, maybe have you ever across a question whereby they gave you maybe a graph of a sine like this way, then it starts here going like that, then they tell you that starting here it's 3, and then also here is 3, -3. Then they ask you to write the amplitude of this graph. Maybe they say y equals to 3 sine x. Okay? So the amplitude of the graph is this 3 there. And then in physical sciences, when we give the definition of this amplitude, is the maximum displacement of a wave from its equilibrium position. So which means is the maximum So is the maximum displacement of a wave from its equilibrium position. So in physical science, in physics, we have a distance and we also have a displacement. So both of them, they sound as if they speak about the from one point to another. So, but they are not the same. When we talk about the distance, when we say distance, when we talk about the distance, if you walked from home, maybe your home, this is your home, then you go this way, you move, you go, then you are going to a shop, then this is a shop. Then the distance is, it's a straight line, goes from there until there. So this is the distance. But when we talk about the displacement, so displacement is starting there when you are moving, you see, going there and until you get to the shop. That's the displacement in physical sciences. So that's the definition, that's the difference between the distance and the displacement. So the distance is just cover straight, whether you were turning maybe with the other straight, you move, you turn again, you go straight, you turn again, you move, you turn again, you move. It does not care, it takes from one point to another. But the displacement, it takes everything, all the steps that we have taken. So that's the displacement. Do you understand it now?
So the displacement is like it's the wave that you actually see.
Yes, it's the actually is displacement, is the directions, all the directions from starting where you started until you ended. Okay, let's say for example, let me give you another example. You see, you might be going, what is it? Like you see an airplane.
Yes.
An airplane, when it travels from one point to, from Johannesburg, for example, to Cape Town, it goes straight. It does not turn because there are no houses.
Yes.
So it use a distance. So, but if you are driving a car, sometimes a road can turn, you go this way, you come this way, you go. You see that maybe you started here, then you turn again, then you turn, then you are here. This is Cape Town because can be a river here. So when if like if it's a train, if it's a airplane, it will just go straight like this. You see, so going straight, we call it from this point to there, because that's how you are supposed to walk. It's called a distance. But going this way, we calculate going this way, this way, this way, this way, this way, this way, this way. That's a displacement. So, which means distance, it can be less than, if you agree with me, based on the sketches that we have been drawing. Distance, I will just use D. It will be less than or equals to, it can be less than or equals to displacement. Do you see that? So displacement can be
Yeah.
high, it cannot be, displacement can never be less than distance.
Okay.
Mm. So those are the terms. So in physical science, especially in physics, make sure that you understand the terms, because they will ask you one question, can be maybe for 2 marks. They will ask you they can ask you the definitions. They can also ask you uh, the examples, like give examples like that. You find that you only know the part of the calculations, but you don't know the definition. So, but when you study them, you can just have a note, like you must have a notebook. In your notebook, just read the in your notebook, just write the definitions properly. Let's say tomorrow you are writing a test, or in 2 days you are writing a test. You can also start reading your definitions based on the chapter that you are writing. You read your definitions properly. When you read your definitions and then you memorize them, you make sure that you remember them. If after that, like calculation part, you will know that you are already been sorted. So when you go, you can start first with definitions. Those you are remember, then you do the calculations. And also a past paper. If you do you have past papers?
No, I don't.
All right. I'm gonna also send you some, not later. I will send you some past papers. So past papers, they will help you to see how we're also gonna be doing also. I'm also gonna do some question on the past paper with you as time goes on. But they will help you to see the structure, how the questions are, how do they ask the questions. So that's
Okay.
yes. So it's very important to, if you need to get distinctions in physics, so that you can also use question papers. Even I used a lot of question papers in order for me to have to get distinction in mathematics and physical sciences. So let's go to sound. We have covered everything that you need to know about the wave. So now we're going to go to sound. Sound, we always use sound every day. So where I stay, I always hear sound, a different sound. It can be any type of a sound. So a sound are a type of mechanical waves that require a medium to travel through. So let me just write this definition for you. A sound don't mind my hand, ne? Don't
Okay.
have a good handwriting. So I was always scared that maybe they will make me fail based on my handwriting. So sound waves are of type So sound waves such as, okay, can be such as water. So it can be such as water and air. So a sound wave are like longitudinal waves, such that which means that in a sound wave, when in chemistry, you are going to learn about the atoms. So in atoms, they will tell you that in an atom, there are particles. Those particles, they always vibrate. They are not always stable. They are always shaking in atoms. So also it applies with the sound waves. So they are longitudinal waves. That means that the particles in the medium vibrate back and forth. So they will always be going up and down, like they are not stable, as I have said. So they vibrate, they do that in the same direction as the wave, as the wave travels. So that's a sound wave. So the sound that we are speaking about is the same. So in this sound wave here, we also gonna speak about the speed, because when you hear a sound, if you are from one point, let's say I'm here, you are in Pretoria and somebody is in Joburg. If I shout, you won't hear me. But if there is somebody here in Pretoria and is very close to me, if I shout, they can hear me, because like, which means when this sound, when I shout and they can hear me, which means there is a distance and then there is a speed that the sound is traveling through. So that's when when we get to the calculation, that's when we're gonna talk about. So this sound, there is a speed of a sound depends on the medium it travel through. So which means when we say it depends, the sound, the speed of a sound, it depends on the medium it travels through. So if you are inside the water, and then let's say you're inside the water, you start shouting inside the water, there is a possibility that I might not hear you. And then it depends where you are. But if you are outside, maybe you are just shouting because of the air. So the air, it can make a sound, it can increase the speed of a sound. So a sound, in general, a sound travels faster through the solids than through a liquid, as I've said. So it depends on and then also a sound travel faster through like air than in the liquids or a solid. So that's a that's just a definition, something that you can also like just a definition to explain about the sound. So this one you don't have to really memorize it, but you must also know that in a house or a room, the speed of a sound is approximately 343 meters per second. So the speed of a sound is approximately 343 meters per second. You don't really have to memorize that. So also, as I've indicated, some of the things I'm not going to write because it's still the same thing as I've been explaining before. So also, as I have indicated, the sound waves can be also described by their frequency and the amplitude. Because if something is vibrating, it's going to start forming what? A wave. So when it forms a wave, the wave, it has an amplitude and then also the frequency. So we must also take that into account. I have already told you what is the frequency. So, but here when we talk about the frequency of a sound, The frequency of a sound waves determines its pitch. Like the way when you say, if you take a record, you say hello and you start shouting, you will see that the way it will show you as a, if it's in your phone, that will show you in a small cycle, but it will be moving up and down. So the movement won't be the same, or the pitch here. So those are about the sound. So the most important thing to take into account is frequency and amplitude in terms of a sound. So there is not much about the sound that I can tell you. So we're gonna move to a light. So after this one here, after the light, we are going to start doing calculations. But I'm going to show you the interesting part that you are waiting for. So light, what is light? So light is an electromagnetic wave that can travel through a vacuum at a speed of approximately 299,792, well, 158. So you don't really have to memorize that for the speed or how that are numbers. So all you need to remember is the definition of a light. So the definition of light is an electro approximately per second. So this is just a definition. So light waves are transverse, waves. So the light waves, they are transverse waves. So what do we mean by transverse wave? So transverse wave, there are particles in the medium vibrate perpendicular to the direction of the wave propagations. So when we say they vibrate perpendicular, so it means that if this wave is going this way, it's gonna form a 90 degrees. It's going to form a 90 degrees. So, but you don't have to take that into account, because when you deal with the calculation, you won't have to reason that up to this much. So also the way, like we have said, so also light waves can also be described by their wavelength. You know what is a wavelength now. Can also be described by their frequency and also amplitude. So you know what is the wavelength already. So now remember, in when we talk about the sound is colorless. Ne? So a light can have different types of light. You have the light that you can see. Sometimes also the thunderstorm, they are a light, remember? So thunderstorm also, they can be classified when you see a blue color. So which means also a light can be determined by its color. A light can be yellow, there is a light, green light, blue. There are different types of lights. They have the colors. So after that, let's talk about reflections. This is now getting close to, we are going to get close to the calculations. So when we talk about we have a reflection, you always do this reflection and then refraction. These are very important terms. You will use them until grade 12, and the diffractions. Reflection, refraction, and diffractions. So what is reflections? You have to know that. I hope you know what is the meaning of reflection so far. Can you also tell me what is the meaning of reflection?
Reflection is like when you can see yourself.
Okay.
I don't know how to explain it properly, but
I understand, yeah. So reflection
like when you look into a mirror or
when,
like into water. Yeah.
Now I understand. So everything that we learn from mathematics, they taught about the reflection of a point. Ne? When they draw, this is in terms of physics and maths, they are, as I said, they are related. So if here is X and Y, if you have a diagram here, then it's reflected here. What is the mean? What is the relationship, or what is the reflection called? We have reflection about the y-axis, reflection about the x-axis. Do you remember them?
Yes, I do.
Okay. So, which means those reflections, you don't have to take them, but just have the knowledge of such things. What is the meaning of that, and then how to change the numbers from y-axis to the x-axis. So therefore, reflection occurs when the wave bounces off a surface and travel back in the opposite directions. So that's the reflection. So exactly what you said, when you close to the water, when you see yourself there, to reflect back, you can see that's also a reflection. So a refraction occurs when wave passes through a boundary between two media and change direction due to a change in the speed. So that's refraction. So you can also read those definitions there. You can also check the definition, you write them down. And then diffraction occurs when waves bend around obstacles or pass through narrow openings. That's a diffractions, not diffusion, diffractions. So those are things that you can read about. So now I'm gonna go through a few questions with you. This one are the most important questions that when we're doing them now, they will help you to understand more about the wave. So I'm gonna first give you the question, then I'm gonna see how you're going to answer, but they are very simple. This chapter is the simplest chapter. And then also electricity is the simplest chapter. Actually, all the chapters, I see them simple. So I think you must get total for them. So now here for the example that I'm going to give you, I will want you to calculate the frequency of a wave, a sound wave. You are going to be calculating the frequency of a sound wave. So I'm going to write a question down for you. This is 0.5. At a room temperature. So the question is, what is the frequency of the sound? What is the frequency of the sound wave? Okay, let me just read the question one more time. A sound wave has a wavelength of 0.5 meters and a speed of 343 meters per second in air at a room temperature. What is the frequency of the sound wave? So let me just do this one for you. So you must also remember the units we use in when we calculate the sound. We use hectares, which is Hz. So you must also know the formula to calculate the frequency of a sound. So the formula to calculate the frequency of a sound is F. We're going to use F, standing for frequency. It's going to be equals to speed. Speed, remember when we talk about the speed is measured in, we are talking about the velocity, a velocity. So which means we're gonna say V over lambda. So lambda means a wave.
Wavelength.
So it's going to be V over lambda. So the V, this one is stand for frequency, this one means velocity, and the lambda means wavelength. So which means you are going to be dividing the speed and the what? And the wavelength, the distance. So when you divide it, when you use that, now it's more easier for you when you know the formula. You can just plug in what you are given. So which means it's going to be 343 divided by 0.5. And your answer, it will be 686 hectares. So remember, here, if you check in this question, here you are given as a meter. Also,
Yes.
speed, we are given that is meter per second, which is meter per second. So when is meter per second? Now, when we take this, if we say meter per second divide by meter, the way we have done that here, this is the same as equals to, it's like meter over second divide by meter, which you can write it as meter over second multiply by 1 over meter. Then this will cancel with this. Then you are going to remain with a 1 over second, which is second. You can write it like that. So which means hectares equals to, you see that.
Yes.
So sometimes you can write it this way, but always make sure that you write as hectares if you remember. But if you are in the exam or you are writing a test, you don't remember, you just have to solve this and you can still write it like this. It's still gonna give you, they will still gonna reward you your full marks. So that was the first question. So which means the formula that you must take into account starting now is going to be frequency equals to velocity over lambda, or V over lambda, or you can just say speed over wavelength, or velocity over wavelength. So that's the formula that you will use for what? For calculating frequency. So this one, let me give it to you, this one. This one, I'm gonna wait for you to do it. It's very simple. It's still the same or the same question. So this one here, we're going to be determining the color of a light wave, A question, a light wave has a frequency So when you see hectares, which means a frequency, a light wave have a frequency of 30 hectares. Okay, then they ask you, what is the color of the light wave? Can you try this one, or is it hard for you?
This one is hard because we haven't started learning about finding the color.
Okay, that's right. I understand. So what exactly did they teach you in the waves in physics?
So we just recently started with the waves because for us in term 1, we started with chemistry, but we learned about transverse waves, and we did questions similar to the first one, but not necessarily about sound.
Okay, no, it's fine. I understand. Then so the color, okay, it's fine. Let me just teach you how to answer this question so that you can know as we already started with it. Then the color of a light wave is determined by its wavelength. That means that it can be calculated using the formula for what? Wave. Remember what is wave? It can be calculated using that formula we used. It can be, let me just write the formula for you down. You can copy the formula to calculate the color wave. Oh, my pen is off. Is lambda equals to C over F. C divided by F. So you might be asking, what is C? So The lambda is a wavelength, and a c is a speed of a light. This is a speed of what? Speed of a light is of a light. And then the f, I guess you remember, is a frequency.
Yes.
So we've been given a frequency in this question here. You see that, a frequency. And then a speed of a light, I already told you, is 299,792,458 per meter per second. So if you want to calculate the color of the light wave, so what you do, you just plug in, you just say lambda equals to, what is your C? Your C is that speed there, 299,7, and this speed, it will be in your formula sheet.
Okay.
Divide by, what is a frequency? The frequency they already told us is 5.5, multiply by 10 to the power 4. So if you use if you remember now, when you are working with this one, if you remember how we do it, it's going to be second per square, or you can just, I'm just saying, if you want to write it, and also meter per second. So you can see that at the end here, when you divide these two, if you say your answer is going to be in terms of a meter, if you say meter per second is the same as you are saying meter over second divide by 1/second, which is meter over second, multiply by second over 1, which you're going to end up with meter. You see, that's the answer, because wavelength is in lambda is in terms of distance. So the color now, when you get this kind of question, then your answer will be, when you can use your calculator, you can just plug in your calculator, then you're gonna get the answer. But the answer here is going to be 545.08 meters, nanometer. That's the answer for your question. That's the answer for this question. So you just have to remember, the most important thing is to remember the formula. So you see that this chapter of the waves, you use more of the same formula. You just, if you remember, if you know the definition, then you can see that, okay, you have a frequency. So the only problem you have, which can you use if you are given a frequency? So you must remember that, okay, if I'm given a frequency, I'm working with light, you go to your back of your question paper, you check, okay, there is you will find, even if you are not really sure, you might find that, oh, they are written the root speed of a light there. So which means I can also use that. You check if in your formula, you have a formula that can work with a frequency and the speed of a light. So that's very simple. So now you can just highlight in your books that, okay, if you want to calculate the color of a light waves, so you use this formula. You can just highlight and then you write this formula. You write also the speed of a light. That C stands for the speed of a light. So the question will come exactly the same way. Just that they won't use this result. They won't use the same one as we are using now. It can be a different one. So you see that physics is very simple.
Yes.
Yeah, so it's very, very simple. So let's go to this one. I think this one, you will be fine with it. So this one we just calculated, right?
Yes.
Calculated the wavelength. We are not yet done with this question. We haven't determined exactly the color waves. So the color wave, when the higher, the longer the distance, There is a table in your books there. I'm gonna try to check a table and I will send it to you so that you can see it. I'm not sure if the table they will write it in your like question papers and every time when I write it, but there is a table whereby it indicates that if you travel this longer, for example, the one that we have now, what is type is determined. For this one that used now, therefore the color of this wave here, the one that we just got, the color of the light wave is green. So I'm gonna show you the table. You can try to memorize, remember it the day you are going to write that, okay, if it's between this and this is green, and if it's between that and that is blue or is red. Yes. So the green light correspond approximately between the green one here. It started between 495 until 570. So if you calculate the wavelength and is in between the range of this, you must remember that is green. But I'm still gonna send you, or have you seen the table that I'm talking about?
No, I haven't.
All right. So this one is gonna be more difficult for you now because you haven't. Did they teach you about the refractions?
No, not
They,
yet.
all right. They haven't taught you that. But does not mean that we must not do it, because now, starting now, you have to also know things that your teacher has not yet taught you.
Okay.
Yes. So the first one we're going to calculate. The second one, we're going to calculate the period of a wave. Calculate what is a period. That's the first question that you must ask yourself. What is a period? A period is a cycle whereby, let me write this one here. This is a sine graph. When we talk about a period, it must complete a cycle. So from here to here, which is 360 degrees, let's say here is 90, here is 180 degrees. So a period, when if we can take this one, we bend it to come this side, you will see that it complete exactly a cycle. So that's what we call it, a period. So when we calculate a period of a wave, is the time takes for one complete cycle, and it can be calculated using the formula. So the formula that we can calculate using it is T equals to, you can also write it down. You just indicate that finding the period. Okay, when I'm writing like this, maybe you can just write, you say finding the period. I'm just showing you an example so that when you are reading, you can remember properly. You can just say finding the period of a wave. When you find a period of a wave, you must say, okay, the formula is T over 1 over F. So what is T? T is then for period. And then F, you know, is frequency. So which means in order for you to calculate the period, you only need a frequency. You see, that is simple.
Yes.
You only need a frequency. So a question says, a wave has a frequency of 50 hertz. It's a very short question. A wave has a frequency of 50 hectares. A wave has a frequency of 50 hectares. Then it says, what is the period? What is its period? Okay. So now, when you calculate the period, you just come in, my t equals to 1 over f. When your t equals 1 over f is the same as 1 over a frequency is 50 hectares. Then what is the answer? Your answer is going to be 0, 0,02. 0,02 seconds. You see now it becomes second. Remember, y is second. Now you know that it's 1 over s, which is, that's why it's like that. You'll see that. So which means therefore the period of a wave is 0,02 seconds. So we spoke about, I'm gonna summarize everything that we spoke and I'm gonna rewrite the formulas properly so that you can also see them. So we spoke about the first one, we're calculating the color of a light. Then the second one, the first one we did, we calculated the frequency. Ne? So now we are going to the period. We calculated it is very simple. You see it. Then let's calculate the velocity of a wave now. Now we are going to be finding the velocity of a wave. So the question says a wave has a wavelength of 2 meters. Oh, sorry, I'm writing with my other handwriting. A wave has a wavelength of 2 meters and a frequency of 10 hectares. So the question said, what is the velocity? What is its velocity? So now, if you have this question here, you have f, for example, okay, you have frequency, which is f, you have a wavelength, which is lambda, you see that. So now you have to find the velocity. So v, you remember that we have calculated a equation whereby we said f, you remember that formula when we say f equals to v over lambda, né? So you can make v the subject of the formula. You just put 1, you do a cross multiple, which means v times 1. This implies that v is going to be equals to f multiplied by what? Lambda. Then you have a formula now for calculating velocity. Your velocity equals to lambda multiplied by f is still the same, or f multiplied by lambda. So if I want to find the velocity of this, I just have to come, I put 2 multiplied by 10, you can equals to velocity. We know that is going to be 20 here, but velocity is in meter per second. You see that this question was very simple. All you need to know is the formula, and then you also need to know how to use the formula. We already used this formula. You just make the subject of the subject of the formula. You just change to make V the subject of the formula. Do you have any question? Hello? Hi, hello?
Hello, I think there was a connection problem.
Yes, I just noticed now that you were not there. So let me just repeat what I was doing. I just noticed now that you were not there. That's why don't switch off your mic, né?
Oh, okay.
Okay. So the question that we were doing, do you still remember it?
A wave has a wavelength of 2 meters and a frequency of 10 hertz.
Yes. And then I gave you did you see the formula that I gave it to you, right?
No, I didn't see the rest of the question.
Oh, okay. So that wave, the formula for a wave, the formula to calculate the period, we were talking about the period, remember? That a wave has a frequency of a wave, okay, it was saying, let me, yeah, it was, we started with the color one, I showed you. Then we went to
Yes.
find the period of a wave, né? Then the
Yes.
period of a wave, I think we did it, whereby
Yes.
period equals to 1 over f. Then the second one we were doing was to find the wavelength. Okay,
Yes.
a wave has a wavelength of 2 meters. And a frequency of 10 hectares. Then the question was, what is its velocity? Eh? So here we are calculating, we have to find a velocity. So we are given that a wavelength has a 2 meters, and the wavelength, remember, is lambda, eh? And a frequency is f.
Yes.
Frequency is f. So before, when we started, we do the first question that we did, you said is the question that you did similar question to that one, whereby you were calculating frequency. Frequency, it equals to velocity over lambda, né? So we make v, because we want to calculate the velocity, we make v the subject of the formula. To make v the subject of the formula, you can just do a cross multiple. Then you say v times 1 is going to be V, which is equals to lambda times F is going to be lambda F. You see that lambda multiplied by F. So which means you can use this formula to calculate the velocity. Then your velocity is going to be equals to, what is lambda? Lambda is 2 meter. You multiply it by frequency. Frequency is 10 hectares. Ne? So you know that always take into, even if you just write that like this, always take into account that velocity is meter per second. Ne? Or you can just write meter dot second like this one. These two things are the same. So which means 10 times 2 is going to give you 20 meter per second. So you see, when you are calculating for velocity, you use this formula is V equals to lambda multiplied by F. You see, that is very simple. You see that in terms of every question that you are doing, in terms of wave, sound, and light, you see that they are very simple. They are just using even a simple formulas. So you just have to know those formulas and remember that, okay, if you are calculating for velocity, this is how your formula must be. And then you just substitute, they already gave you the answers there.
Yes.
Then we're still gonna do a little bit harder as time goes on, but this one we are going to finish it today because it's very simple. Yeah. Then now we're going to go to, but I don't know if you haven't done this one, calculating the index of refraction.
No, we haven't done that.
Okay, so you can take note of it, and plus I'm still going to send you this video so that you can also reflect back on how to do it. So I'm gonna just write we are calculating the index of refraction. A light wave traveling in air. This is a question. Let me just write it down, or should I just read it to you?
You can just read it to me, it's fine.
Light wave traveling in air with an angle. I will just write it a very important things. A light wave traveling in air with an angle of incidence. This means angle in mathematics or physical sciences of incidence of 30 degrees. Encounter a boundary with a material with an angle of a material with an angle of refraction. Of 45 degrees. What is the index of, the question says, what is the index? What is the index what is the index of refraction of the what is the index of refraction of the material? Of the material. So this is the question, what is the index of refraction of the material? So in this one here, because it's the first time you are doing it, I'm going to be highlighting the most important things that you have to take. The index of refraction can be calculated using a Snell's law. Ne? I'm gonna erase here. So the index, I'm gonna write this one because it's very important. the index of refraction can be calculated, Snell's law. So what is a Snell's law? You must know the meaning of a Snell's law, which the Snell's law states that if you have n1, I'm gonna tell you what is n1, sine of theta, n1, again, this is the same n1, or not n1, sorry, sine theta. Let me erase here. It's gonna be sine theta 1 is equals to n2 sine of theta 2. So where n1 and n2 are the index of reflections and angle of incidence. So this one is the index of refraction, and also the theta 1 and theta 2, or theta, they are angle of incidence. So which means if you have, because here the question, if you are there in that question, if you have seen it, we have two things that we are calculating. That's why we have 45 degrees, we have 30 degrees for the first one, and the other one is 45 degrees. So when we calculate using that, this one here, and then when we calculate using that, we use this formula to calculate. So which means, remember that when you are calculating the index of refraction, this is the formula that you are going to use. So when we use that formula to calculate the index of refraction, we're going to plug in this one that we started with. So which means the first one here, the first one here, in that question there, we are given 30 degrees with it says, let me just read it so that you can remember. A light wave traveling in an incident, a light wave traveling in an air with an angle of incidence of 30 degrees encounter a boundary with a material with an angle of refraction of 45 degrees. What is the index of refraction of the material? So now when we use this formula, the N1 is going to be the first material. So the first material, that's why we write N1. You're gonna write 1, then you say sine of, and then sine of, we were given 30 degrees, 30 degrees, then equals to, for the second one, because we have to calculate what the diffraction, or diffraction for the second one, N2, we don't know what is N2, but we are given the degrees, which is sine 45. We are given 45 degrees. So now we are going to use this formula to calculate the N2. So N2 that we are calculating, this is the N2 that we are calculating, that's the index of refraction. This is the index of refraction. Are you still here?
Yes, I'm still here.
Okay, I thought maybe you are having a network connection. So when you're just gonna divide, which means it's just gonna be sine of 30 degrees, you divide it by sine 45 degrees. So sine 30, you know that is 1 over 2, or you can write as 0.5 divided by, and then sine 45. Sine 45, you use mathematics, you use Pythagoras. When you use Pythagoras, remember sine 45 is 1, So sine 45 is 1 over square root of 2. You remember that? Have you done that in maths?
Yes.
All right.
Yes.
So now when you do that, your answer will be 2 square root of 2 over 2. Yeah. And then this one, if you when you square root of 2 over 2, if you use your calculator, it's gonna be 0.817. So that's the refraction of what? That's the angle of refraction. That's the index, or the index of a refraction. So in that question, I didn't explain something properly to you. I'm going to write the formula again so that you can understand it properly. So when you are calculating the index of refraction, you will be given an angle of incidence, right?
Yes.
And n, this n here is for the first material, but we refer to it as an angle. They will give you an angle of incidence of 30 degrees encountered with a boundary. After that, this one here is going to be n, is going to be for the first material, né? It's going to be an index of incidence. So an index of incidence, sometimes they can tell you what is it. If they don't tell you, you must use 1. So this n here is the index of diffraction. Also not diffraction, refraction. Is the index of refraction. So the index of refraction is the one that we are looking for. We have to calculate. So here you're gonna have 2 objects, the first object and the second object. So that's you are going to be, it's like we are comparing, in other words, we are making them all equal. So the index of diffraction is n2 for the n2. Sometimes it can be they can start with the index of diffraction. It can be n1, but you are still calculating the same thing. You see, so it depends on the structure of the question, how it is. And just because now we calculated the index of diffraction, they can want you to calculate the angle of incidence. They can want you to calculate the angle of refraction. It depends on the structure of the question. The question, you can learn it today in this format, but it does not necessarily mean that every time they will want you to calculate N2. They will want you sometimes to calculate theta 2. They might want you to calculate theta 1. It depends how the examiner structure the question. So I hope you understand what that.
Yes, I do.
Okay. So you see, this chapter is very, very, very simple. So now, as you are saying you do, I'm going to give you this question. I'll write it down. I want you to try to do it. It's exactly the same way as the one that we just do now. So now you are going to be calculating the angle of refraction. A question says a light wave traveling this one is yours now. A light wave traveling in air with an angle of incidence of 60 degrees encounter with a refraction, with index of refraction. So now you see that in this question here, they gave you an index of what? Of refraction. Eh?
Yes.
Then they ask you what is what is the angle of refraction? So it's fine. Let me just help you with it. Then I'm just gonna give you yours later. So that because it's a new thing to you. So this question is exactly the same question as the one we were using. So there you are given the angle of refraction. Then we have to calculate. You can use the same formula that I gave you, N1 sine theta 1 equals to N2 sine theta 2. You have this angle. We also have 60 degrees. We have 60 degrees for N1 for incidence. And we also know that incidence is what? Is 1. Eh? So which means it's going to be 1. Then which means here when we calculate it's going to be 1 sine what? Sine 60. Eh? Let me write it. Can you see what I'm writing?
Yes, I can.
Okay. Sine 60 degrees equals to N2, they say is 1,5. Sine what? Sine theta 2, we don't know. You see, so now if we don't know sine theta 2, what we gonna do, which means sine theta 2, sine of theta 2 is equals to what? 1,5 over sine 60, eh? You see
Okay.
that? Oh, sorry, I did a mistake there when I'm dividing. If I divide by 1,5, it's going to be sine 60 degrees over 1.5. You see that? What is sine 60? 30 and 60, 1 square root of 2, then here is going to be square root of 3. Sine 60 is equals to square root of 2 over what? It's square root of 3 over 2, ne? Then it's going to be equals to square root of 3 over 2. So what is square root of 3 over 2? You can use a calculator, but I'm just going to write square root of 3 over 2 divided by 1.5. So when you say square root of 3 over 2 divided by 1.5, the question is not yet there. We are not yet done there. So this question here, approximately this one, you're gonna see that is, if you use your calculator, is 0, 577. So I'm gonna erase a few part here. Let me just erase this side. Okay. Oh. So now we have sine 2 sine theta 2, which is equals to 0, 577. So now we're going to have sine theta 2, which comes to 0, 577. We're going to left when we say sine 2 is going to be equals to arc sine. This is called arc sine. when you write it like this, 0,577. This is called accent. Do you have a calculator with you?
Yes, I do.
My calculator, the accent of that. Then 2 is going to be approximately 35.26 degrees. Did you also get that?
Yes.
Okay, so this is how you normally do it with the when you are calculating the what when you are calculating the angle of refraction. So the other part is for incidence. If you have noticed, is for incidence. The other part is for refraction. So that's how simple it is. All right. So do you have any questions so far?
No, not really.
Okay. So this is everything that you need to know with waves. If you understand everything that we have been doing today, it means that you understand the wave, light, and the sound. So any questions that you are going to get, you won't fail it. You will get it. I'm still gonna give you more questions. I will send it to you. And then how is it like, are you finding maths difficult or how is it to you? I mean mathematics?
With math, I'm doing well.
That woman, what is
Like
your
my average for math this term was 75%.
okay, so you are owing 25 to get 100.
Yes.
So you have 25% problem. All right. And then for physical science, what was your average?
We haven't calculated the average yet, but for my exam, I got 58%.
I mean, like, sorry, I mean, when I say like, I mean, since you were like, since you started writing maybe the test, how much were you getting so far, like a test, like the score?
I've been getting 50s.
50. So, okay, you are owing 50%. All right, no, it's fine. That is a good start. It's not really bad. Then it means that you must aim for 100, né?
Yes.
All the modules that you are doing, you must aim for 100% because students are getting 100% when they come to universities. Like they come with 100. Yeah, you get what I'm saying. So aim for 100 so that you can get 100%. It's very possible to get 100% in maths and science.
Yes.
Okay. So if you are saying it's fine, then I'm also done with your what I'm supposed to teach you today. Then I'm just gonna send you the video so that you can reflect back on today's lesson.
Okay.
So as to, are you available tomorrow?
I'm not really sure. I'll ask my mom if there's anything we have to do tomorrow.
Okay. And then when are the school closing?
I'm closing next week, Thursday.
Next week, Thursday. And then on Monday, I think it's holiday, ne? Are you also available?
Yes.
Monday, ne?
I think I'll just have to ask my mom if there's anywhere we have to be.
Okay, okay, no problem. And then the other thing that I'm gonna ask, what did you said you also touch chemistry now? What have you done in chemistry?
In chemistry, we did electron configuration.
Okay.
We also did um structure of the atom. We did the chemical bonding.
Chemical bonding, okay.
With the Lewis dot diagram.
Oh, okay. So which
And
means like,
we covered ions.
okay. Which means for physics is only, you only did this chapter only.
Yes, because we just started with physics. Because we started with chemistry, it was our term 1 topic. And then since we finished with chemistry, we started with physics this week.
Oh, all right. So which one between physics and chemistry, which one is it giving you problem? Chemistry or physics?
So far, physics hasn't been really giving me a problem, but it was chemistry.
Or chemistry?
Because in my exam, what I noticed is I would get the answer right, but I would leave out things, and that would cost me marks.
Oh, okay. No, I understand. All right. Then
So
we're
it
gonna,
wasn't wrong. So I just had to add more, but I didn't. That's why I lost a lot of marks.
oh, then so which means like your mom will confuse me if you will be working between today, tomorrow, and today. Let's say Monday, if you will be available.
Okay.
Yes, I'm gonna fill a form. I'm gonna send it to you. Then you're gonna just sign it that we have a class there. And can you sign some
Okay.
like using your phone or you send it back?
Yes, I
Okay,
can.
okay, no problem. I'm gonna send it to your mother.
Okay.
All right. Then have a good day.
Thank you. You too.
Okay. Where do I go now? Let's see.